In this segment, I want to talk about processor design and evolution, including covering how processors are actually made, the changes in technology that have occurred over the years, as well as changes in packaging and power consumption. Now, when most people think of a processor, they think of a chip like this, for example, this Intel Core i-series processor that I have here. Now, when most people look at this, they say, oh yeah, that's a chip, but what they're really looking at is the package. What I'm really interested in, what we're going to talk about more here, is what's inside the package. Now, in this cutaway view, I have a magnified image of one of Intel's latest Core series processors, and underneath this metal cap, you can see the actual processor die. The die is the actual circuit that comprises the processor. Now, this circuit is incredibly complicated. These circuits can have upwards of 1 billion or more transistors in them. So it's an incredibly complicated circuit. In fact, I would have to say the processor is one of the most complicated components that is manufactured by man today. So let's look at how these things are actually made. Well, processors, the raw material that go into processors is silicon. And I have an example of a chunk of pure silicon right here. Now, silicon is the second most abundant element on the planet. The only thing that we have more of is oxygen. One thing, though, silicon is rarely found in any kind of a pure form. It's mostly mixed with oxygen in the form of silicon dioxide, which most of us know as quartz or sand. So, in fact, sand is mostly silicon. So, many times you've probably heard that, electronic circuits are made out of sand, and that's largely true. So what happens is we take the sand, melt it down, and put it through a purification process until we extract the 99.999% pure silicon. Now, even that's still not ready to make chips out of. We need the silicon not only to be pure, but to be in the form of a crystal. So what happens then is the silicon, the pure silicon, is melted in a vat, and a seed crystal, like the one I have here, is dunked into the vat of molten material. It's slowly turned and then pulled out. Now, if you imagine this vat of molten material, it's kind of like melted glass. It's sort of thick and taffy-like. And as the crystal begins to pull out, some of the material sticks to it and begins to harden. So what happens is this seed crystal pulls out of the vat, and you can see a bunch of material sticking to it. And they pull at first rapidly until we have a very thin stem forming, and then finally more slowly until a wider and wider crystal begins to emerge from the vat. This is an example of a pure silicon crystal that I have here that was grown in one of these vats. As you can see, the shoulder of the crystal gets wider and wider as it is pulled out. This is like millimeters per hour. It's a very slow process. Now, once the crystal reaches the diameter that is intended to be, then the process speeds up a little bit. It's pulled out a little bit more quickly until basically what we have is like a cylinder. Imagine a cylinder of this crystal material being pulled out of this vat. Once the cylinder has reached its final length, which is usually a couple of feet long, then the pulling process goes more quickly and we end up with a tail. They want to actually have a sort of a gradual pull out of the material from the vat to prevent any kind of thermal shock. Now, the tail on this crystal is very short. It's very short here, as you can see. In fact, this was an aborted crystal process. Normally, the main body would be not just an inch here, but would be several feet tall. This, in fact, is here as an example of a tail of a more complete crystal. So if you can imagine, this thing was several feet tall, and then this was the tail that's basically cut off and is considered waste. The head and the tail are then chopped off of this crystal. So now what we have is this cylindrical crystal of silicon. Head and tail are cut off. This is then put into, it's ground so that it's perfectly round, and then it is put into a saw that cuts it into thousands of plates called wafers. I have an example here of a wafer that was cut from one of these crystals. You can see that it's round and is very thin. It's less than a millimeter thick. Thousands of these usually come out of one single crystal. Now, the wafer would then be polished to an absolutely flat surface, better than most mirrors, a mirror polish. And then what we have is called a wafer, and this is the sort of the raw base building material for making chips. Now, what happens is the wafer is put into a process that's a photolithographic process. We take a mask, which is, you could call it like a negative. We shine a light through it, and we literally etch the various dye into the wafer. I'm going to show you an example here. This is an example of a wafer that has 177 finished dye etched into it. As you can see, they're just one after the other, rows and rows and rows of them. One mask was used to produce this, or I should say one collection of masks, because each of these dye is not just one image that's put on this wafer. It's a stacked series of images, usually 20 or more layers. And through the photolithographic process, material is coated onto the wafer, then it is etched with the ultraviolet laser, then portions are washed off, and we literally have like a cake building process, a layer upon layer upon layer, until this very complicated series of circuits is assembled. Then, once the wafer is complete, the individual dye are then cut out of it. So we end up with individual square processor die. Now, a typical die, might be something on the order of these sizes here. I have I made up some pieces of paper that are about the size of most modern processor die. They can be anywhere from usually 10 millimeters to 20 millimeters square on each side. Some are more rectangular, some are square. Okay, so now we've seen the basic, building process of making processors, but let's take a look at how this technology has changed over the years. Processors have been made for nearly 40 years now. The first one came out in 1971. What was different, from then to now? Well, a couple of things that have changed. One is the size of the wafers. This is an example wafer from around 1973-74 when they were 3 inches in diameter. As you can actually see, this one has a series of chips imprinted on it. This one was never cut. The chips were never cut out into the separate die. Now, wafer sizes have increased over the years. Most recently, we had a transition from 8-inch wafers to 12-inch wafers. And what that means is that the wafers that are being used for most chips today are 12 inches in diameter. Now, as the wafer size increases, the number of chips that can be imprinted on them go up. For example, this wafer image that I have here was actually originally an 8-inch wafer. And with the 8-inch design, 177 separate chips could be etched or fit onto this wafer. Well, when this was increased to 12 inches, they began making the same chips on a 12-inch wafer. They were able to make 449 chips on the same exact wafer. So in the same amount of time, they are now making, nearly or more than twice as many chips. As the wafer size went from 8 inches to 12 inches, the surface area grew grew 2 1/4 times. So we can have literally more than double the number of chips being produced. So these are some of the technology changes that have happened. The wafers have gotten bigger. One other thing has been going on, though. The componentry that goes into each of these die has become smaller and smaller. When processors were first being made, the very first processor in 1971 had components spaced 10,000 nanometers apart. That's 10,000 billionths of a meter. Today, we are making chips with the componentry spaced only 32 nanometers apart. That's hundreds of times more dense, more components fitting into the same space. So while the die of a processor has remained relatively the same since about when the 486 came out in 1989 to the present, the actual individual size of the processor chip within the chip has remained the same. But the number of components has gone up tremendously. The 486 had 1 million transistors on it. Today we have processors approaching 1 billion transistors. So, as you can see, the 2 big changes that have occurred in processor manufacturing is going to larger and larger silicon wafers on which we etch the chips. And then each die, while the die has remained relatively the same size over the years, more and more components are being crammed into them. Now, let's take a look at sort of a timeline of processors over the years, PC processors especially, and look at how not only the processors have changed, but the packaging and cooling issues as well. I have assembled here nearly 40 years worth of processor history, I thought we could take a look at this. Now in 1971, the very first processor that was introduced